Why does fire exist?
The flames we invite into our lives take many forms, each offering its own unique warmth and story. Before the flame erupts, there is a hidden interaction. Countless oxygen molecules drift slowly toward the hubers. As these atoms approach, the repulsion between their electron clouds causes a sudden bounce. See how it rolls up but hits this invisible wall? It just bounces right back.
The first break occurs as oxygen atoms collide with the carbon structure, snapping a bond and releasing bursts of energy. The heat intensifies, breaking bonds. Suddenly, collisions multiply and the first flames ignite. Here, heat takes control. The flames spread confidently, establishing a self-staining reaction that consumes us. Did you know everything is always moving? It's this invisible atomic chaos that, at this point, the bonds snap almost simultaneously. The energy surge is inevitable, and the immense power you witness is the sum of countless tiny collisions deep within, releasing energy that cascades outward.
Fire propagation isn't just random burning. Heat builds, releasing flammable gases, and forces the flame by just one element of the fire triangle, and the reaction fails until the fire completely dies out.
All the ingredients are present, quiet, dormant, and waiting for the right trigger to unleash their energy. Many think trees grow from the soil, but they actually absorb the carbon they need directly from the air.
Carbon from the air builds the tree. When burned, it disappears, leaving only the minerals absorbed from the soil. While the soil remains unchanged, the tree's mass increases substantially. Proving the material is absorbed, the tree captures the radiant energy of the sun, transforming it into vital fuel stored deep within its trunk. It begins with a single spark, erupting into a chain reaction that transforms silent wood. Deep within the wood, carbon and oxygen atoms snap together, releasing the stored power of sunlight as brilliant rays blends. The vibrant colors of the flame are born from within, as atoms release their energy in bursts. As heat rises, atoms vibrate and collide more energetically, bridging microscopic motion to the bright lights. When electrons absorb heat, they jump up, and when they fall back, they release energy as vibrates. As the combustion completes, we see the separation. Tiny carbon fragments float upward as smoke. Why doesn't wood spontaneously burst into flames? It's because these atoms lack the requires. Why doesn't wood just burst into flames? Even though burning is favorable, it needs an initial push. All that potential energy waits for a single moment of activation. And then, the combustion becomes a self-sustaining chain reaction. Heat transfers to the next fuel source, causing the flame. Wood, gasoline, and even the sugar in your cells exist in metastable states, holding energy, causing the flames. Wood, gasoline, and even sugar represent metastable states, holding energy that appears stable until. Every breath we take begins here, as these magnificent trees silently release pure oxygen. Photosynthetic organisms evolved, releasing oxygen that gradually accumulated in the atmosphere. As animals eat plants, they obtain stored carbon, while oxygen is released back into the atmosphere. Cellular respiration releases energy slowly within cells, while fire releases energy rapidly. How does wood turn into fire? At the atomic level, chemical bonds snap during combustion. At the atomic level, absorbed heat forces electrons into higher orbits. As they fall back, different elements emit distinct colors when heated. Sodium gives us yellow, copper creates green, and nicks. What remains tells the story of combustion. Smoke curls upward while ash and tiny carbon particles.
As the last flames vanish, the wood's mass is converted into these rising gases, carbon dioxide. Just as a spark ignites the wood, a small nudge overcomes this boulder's energy barrier, causing it to rise.
The intense heat releases energy, igniting new fuel in a rapid transfer.
Wood, gasoline, and the sugar in your cells all store immense potential energy in a metastable state. Here, plants use sunlight to take in carbon dioxide, splitting the molecules and releasing pure oxygen babas. Bathed in golden light, the leaf captures energy, crafting structure while gently releasing the air. You're looking at ancient sunlight, captured by a tree, and now unleashed again as heat and light.
Fire is frozen sunlight.
You are not just watching wood burn. You are watching ancient sunlight being released.
This is the heart of the reaction. As these bonds break, stored energy erodes. Fire never ends. It just changes form.